Hello, everyone. Thank you for coming to my session. Maybe somebody of you was in my LCA session early this year at Christchurch. I just want to clarify, this is not the repeated session. We do have something new about, for example, rolling upgrades or AutoHealing stuff. I'm Feilong. I'm the head of development at Kiwiscout, and I am a long-term contributor for open source about since 8 years ago for OpenStack, and recently starting to contribute to Kubernetes stuff. You may not hear about Kiwiscout. We are the onshore public cloud provider, and meanwhile, we can provide private cloud solutions as well. And I just want to highlight one thing is we can also provide comparable price with the other cloud providers over the seas. Currently, we have 3 regions across North Island, currently South Island. We have 1 region at Wellington and 1 region at Hamilton and Porirua. So back to the topic today is about Kubernetes. So before I start the session, I just want to ask some questions. Is there anybody never heard about what is Kubernetes? Still okay. And is there anybody is using Kubernetes on production? Cool, not too much. So another thing about Kiwiscout is we are the first and so far the only one Kubernetes certified service provider in New Zealand. And meanwhile, we can provide the certified Kubernetes based on the CNCF certification. I highlight that because I think it's very important because the portability for Kubernetes in the container world is very important. The certification from CNCF can give you a guarantee you can move your workload from one Kubernetes from, for example, AWS, the EKS to GKE or any other cloud provider if the cloud provider also got the CNCF certification. So that guarantees the portability between different Kubernetes services. And because this is the kiwipycon, actually the tool we are using to deploy Kubernetes is based on Python code. We are using OpenStack Magnum. OpenStack is an ice-layer open-sourced platform, and we are using it for public cloud. And recently, about 1 year ago, we started to use OpenStack Magnum. OpenStack Magnum is a project name. The project can help users to deploy different different container orchestration engine, except Kubernetes. You can use OpenStack Magnum to deploy Mesos or Docker Swarm as well. But so far, for us, for Kiwiscout, we just use OpenStack Magnum to deploy Kubernetes because I think at current market, not too many people talking about Mesos or Docker Swarm for running their container workload. So this is the dashboard. I would like to give you guys a live demo later at the end of this session, so you can take a look at the dashboard. And you can also use a command line to, for example, the Python command line or the Ansible or Terraform to talk to the OpenStack Magnum API as well. So the topic is about production ready. I think for different people, they have different view about what is production ready. But for us, we are a public cloud So we think about the whole things from a public cloud perspective. Because OpenStack is an open source project, so there are different parties, companies, organizations from worldwide. They have different interests for the projects. But for us, we just care about the things from a public cloud perspective. For example, I can give a sample. In the OpenStack Magnum community, CERN, the European Organization for Nuclear Research, they're also a major contributor for OpenStack Magnum. They're using OpenStack Magnum for Kubernetes in CERN as well, with a very large scale. And SK, if you have heard about SK also using OpenStack and Kubernetes. So the first thing for a public cloud for production ready, the thing we care about is the strong security. So we would like to support rolling upgrades and patching for both the Kubernetes and the operating system running for Kubernetes. As you guys may know, Kubernetes has a very frequent release. For 3 months, there is a new version. So it's good. It's good because there are some new features or bug fix, but it's also a pain for user, for cloud provider to support the upgrade to a new version. And another thing is authentication and authorization. We are using, in OpenStack world, we are using Keystone, OpenStack Keystone for the authentication and authorization. So for our work, we are working on a webhook so that you can use your existing OpenStack user for Kubernetes as well. So it's integration for the authn and auth. Another thing is the network policy. The network policy we're talking about is in the Kubernetes world. Currently, we're using Calico as the CNI plugin for network policy. The next thing is high availability and resiliency. So we would like to have high availability for master nodes. So you have to create 3 master nodes or 5 or 7 master nodes for your cluster because you have to keep the HA for your etcd cluster. Currently, all design, the etcd will share the same node with the master node. So because etcd needs the odd number for the high availability, so we need the master have the odd number as well. So generally, at least, you need to have 3 master nodes. And another thing is the failure detection and auto-healing for both master and worker nodes. If you are familiar with GKE provides a feature named auto-repair. It's the same, the auto-healing is basically the same thing. So the simple story is when there is a node, for example, a worker node is done, there is a service, we call it Magnum auto-healer, is running on the Kubernetes cluster, will periodically detect the failure for the worker node or our master node, and it will trigger a repair to replace the broken node with a new one. And the next thing is the performance and scalability. So for network performance, as I mentioned about, currently we're using Calico because based on our testing, we tested Feilong and Calico, but Feilong's performance is not good on our cloud. And because we need the network policy as well, so finally we select Calico as the CNI plugin. For storage performance, actually we didn't do anything. It's just used the out of tree from cloud providers, OpenStack. So it can provide the integration between OpenStack block storage with Kubernetes, and we can get basically the same performance as the S layer. So it's good. And we can support in OpenStack Magnum, we can support the horizontal scalability with AutoHealing or manual auto-scaling and manual scaling. We provide the auto-scaling based on the Kubernetes cluster autoscaler. There is OpenStack Magnum driver contributed by CERN. So it will monitor the workload on your Kubernetes cluster. If there's any pod impending status, it will try to call the OpenStack API to scale your workload number. And you can definitely use the API from OpenStack perspective, Magnum perspective, to trigger a resize, to resize the workload numbers manually. It's easy. And easy of use. With the, as I mentioned, with the OpenStack, with the cloud provider OpenStack, we can get out-of-box integration between the OpenStack and Kubernetes. And for Magnum API, we can provide the OpenStack Python client support. And meanwhile, you can use Ansible or Terraform to talk to the API as well. So it's very handy. So one thing I would like to highlight is all the work we are working are open sourced. So we are not selling something. We just want to share the journey we, from the design and implementation. So for the software, it's quite simple. It's a very standard Kubernetes deployment. On the master node, you have API, scheduler, controller manager, proxy, and kubelet. And at this moment, we are using Fedora Atomic as the base operating system for master node and worker node, because based on our experience, we have already benefited from the containerized read-only operating system. And we have a CI/CD. We even have a CI/CD pipeline for to build the Kubernetes, original raw image, because we had run into a problem. There is a bug fixed in master or very latest branch in Kubernetes, but it takes a very long time to backport to the version we support on our production, on our cloud. So we have to, at that moment, we have to build the CI/CD pipeline so we can get the Kubernetes image, the component image for the fix for our user. And with that CI/CD pipeline, we will run the conformance testing, the Sonobuoy testing for CNCF certification. So to get the certification, some basic conditions is the first thing is you have to be a member of CNCF or Linux Foundation. The other thing is you can pass the conformance testing for CNCF. And the other reason we use Fedora Atomic is because it's easy to patch and upgrade because it's based on the RPM OS tree. And for each time when you upgrade the system, not the system, the Kubernetes version, you can easily download the new Kubernetes component version and just run Atomic containers update if you update the old version, replace with a new version. So this is a standard architecture when you deploy a 3-master, 3-worker Kubernetes cluster. And this chart is about the end hood topology. So in OpenStack Magnum, we are using, under the hood, we are using OpenStack Heat to deploy the S layer resources, for example, the compute node, the storage, the network, the load balancer. So Heat is doing the thing. You can take a hit at the similar thing like CloudFormation at AWS. You do the orchestration work. And for authentication and authorization, we are using Keystone. Keystone will do as a IAM backend. And there is a webhook. The webhook can do the auth and auth between the Keystone, the OpenStack Keystone, and Kubernetes. It's also open sourced, hosting in the same repo of cloud provider OpenStack. And for networking, I won't go through the details for those three charts. I just want to highlight three very basic policy when you play with Kubernetes about the networking stuff. The first thing is containers need to compute with each other without NAT, and the node can also communicate with any nodes without NAT. And the IP that a container see itself as it's in the same IP that the other see it is. So with Calico, that you can easily meet the basic requirements. And the cloud provider OpenStack. So currently, for different cloud providers in Kubernetes community, they have put them out of the Kubernetes source code tree. So now you can see there is a cloud provider AWS, cloud provider GCP, cloud provider Azure, cloud provider OpenStack. So with that cloud provider, it's basically do the thing between Kubernetes and your Kubernetes cluster, the OpenStack and your Kubernetes cluster for all the things running on the S layer. For example, the compute, storage, network, load balancer, and the auth and auth. And this is a standard deployment on our cloud. So as you can see on above, you can see there is a Kubernetes Keystone auth. That's the demo site for the auth and auth between OpenStack Keystone and Kubernetes. And there is the OpenStack Cloud Controller. That's the cloud provider, as mentioned, can help you for the other things like networking, load balancer, storage, etc., between Kubernetes and OpenStack. And this is the OpenStack Magnum AutoHealer. That one we just open sourced recently and contributed back to the community. It can heal, repair your cluster when there is any node is down. And and there is a Calico node running on each node. No matter it's master or worker, there is a Calico node for networking stuff. And you also can have Hipster as a deployment and core DNS. And a kubeDNS autoscaler can help you to scale, auto-scale your DNS, core DNS port. And the Kubernetes dashboard and Grafana, Prometheus, and this is the Calico controller. And you can also have the cluster autoscaler. It can help you scale, do the autoscale for your work node. So for all above stuff is the thing before you create a cluster. But after you have the Kubernetes cluster, there's still something very annoying from a user perspective. For example, from the ongoing management perspective, the first thing is a rolling upgrade. As mentioned, Kubernetes will release a new version for every 3 months. It's very frequent and is bringing a lot of pain for both user and cloud provider to make sure you can always upgrade to a new version to get the new features and the securities patches, for example. So this is the new thing we recently introduced in OpenStack Magnum, the rolling upgrade. So with rolling upgrade, you can just trigger a very simple command line or do it where the dashboard. We haven't finished dashboard work, but you can use the command line. OpenStack COE. COE is the container orchestration engine. COE cluster upgrade and give it the current Kubernetes cluster ID, and then you can give it a new cluster template ID. In the new cluster template ID, you can have the, for example, the new image of the node you would like to upgrade to, or you can also give a new Kubernetes version. For example, if you are running on Kubernetes v1.11.9 and you would like to upgrade to v1.12.7, you can just give the new version in the new template, and OpenStack Magnum will do the magic to upgrade your cluster to the new version. And the other thing you may be interested in is when you do the rolling upgrade, will my service application running on the Kubernetes cluster be affected, or there is any downtime during the rolling upgrade? The answer is no. There is no downtime, and the design and implementation from OpenStack Magnum perspective is quite simple. This is the process. The first thing, generally, we just iterate each node, for example, worker nodes. The first thing we like to do is cordon. So cordon means currently you can schedule any workload on that node. And then the next thing is dream. Dream means I would like to trigger the rescheduling for all the pods, workloads running on that node to the other worker nodes, so that I can do the upgrade. And then just upgrade. As I mentioned, with Fedora Atomic, the upgrade is quite simple. You just need to download the new container image with Atomic command, and then run Atomic containers update. It will update the old Kubernetes components with the new one. And the last thing is just uncoding to make sure the node can be back for any new workload. But that's not enough. There's still some things the user need to be done from a user perspective. The first thing I would highlight is you need to make sure your application service is managed by a controller, for example, by a deployment, and make sure you can get replicas more than 2 or whatever you want, but more than 2 is nice. And another thing is you'd better use the pod disruption budget policy, because I would like to give a chart to explain it more. So the important attribute you want to pay attention is the minimum available. So I just give it for 1, or you can give it 2 or more. So let's imagine the rolling upgrade process. I have 3 workloads, and I have upgraded the node 1 and node 2, and I have Nginx service application running on the cluster, and it has 3 pods. Initially, it should be running on each worker node, but after the rolling upgrade process, now the Nginx pod 1 and pod 2 has been rescheduled, dreamed. Actually, it's dreamed on the node 3. But at this moment, if you just trigger the dream, the Kubernetes dream for the last worker node, there is a case that all the 3 pods will be triggered, rescheduled to the other 2 nodes. And at that moment, you get a downtime for your application. So that's why we would like to have the minimum available, the pod disruption budget for your application to make sure anytime when the Kubernetes got a command Kubernetes drain, it needs to make sure, Kubernetes need to make sure there is at least one pod is alive to make sure you won't get a downtime for your service. It's very important. And the last thing is you need to make sure your application can support the term signal. If it doesn't support, you should use the pre-stop hook. For example, Nginx doesn't support the term signal, so you have to use the pre-stop hook to gracefully shut down your Nginx service. Otherwise, there's still, small chance to get a downtime for your service. And another case, a corner case, is the sleep. The sleep is very tricky because you can imagine for that case, because you could have a load balancer before your service. So when there is traffic, when you're doing the drain or the cordon, for example, the drain, there is still very small chance there is still traffic from outside for your service. And but at the moment, the stop notification hasn't arrived on your work node. So it would be nice to just give it a sleep time or just a wait time to make sure your work node, your service can get a really gracefully shut down. But just for the case if your service application doesn't support the term signal. And the last thing, the feature is the AutoHealing. So the AutoHealing is very tricky because the scenario is like you are trying to replace the engine when the airplane is still flying. So you would like to make sure the cluster is still alive and no service is being affected. And at that moment, you are doing the repairing, doing the healing for your cluster. And that needs the Kubernetes AutoHealer, or you can call it a Magnum AutoHealer. And it is also fully open source. But the only thing you guys may don't like is written by Go language, not Python, because we contributed it back to Kubernetes community. You can find it here. It's under the Kubernetes Cloud Provider OpenStack repo. It's fully open source. Currently, it only supports OpenStack as the driver, but you can definitely write a driver for AWS or Azure. I think only at this moment, so far, only GKE support the auto repair. EKS and AKS doesn't support AutoHealing. So if you want, you can just take it and write a driver for AWS or AKS. And you can predefine some failure detection policy to detect what's the failure you're interested in when it's happening. I would like to give a live demo and before the roadmap stuff. So I just created a 3 master, 3 worker cluster on our cloud. And you can see there is those 3 master 0, 1, 2, meaning 0, 1, 2. Now I'm going to message. So as you can see, we have the AutoHealer demo site here. And because there is a leader election, so we need to make sure which one is a leader so that we can see the log. KKS logs. I think this one. So this is the leader. It will periodically check the health status for master and the worker. Currently, the default periodic is 30 seconds. And now we are going to we can just shut down one of the worker node and see if it can be repaired. We can log into the we're going to shut down this one, and we can log into the master. So currently, all the three nodes is valid for the minion one is in ready status. It may take 30 seconds to detect the failure. But from the Kubernetes perspective, generally the default periodic check time is 10 seconds. But for the AutoHealer, it is 30 seconds. I'm not doing the minion one. I did the minion two. So you can see it's in not ready status now. And let's check the log of the AutoHealer. So AutoHealer is still saying everything is good. OK, so the AutoHealer has found the node minion 2 is unhealthy. The ready status currently is unknown. So it may take, by default, it will wait for a period. Currently, the default time is 3 minutes. It will wait 3 minutes to replace the broken node. But you can change, you can define the policy. You can wait 10 minutes or longer. So we'll come back after about 2 or 3 minutes to see if the minion tool will be get ready. It'll be replaced, actually. And back to my session. So there is still something we would like to do. Currently, we are still working for upstream for OpenStack community is to support choose the volume type for etcd, for both etcd and the root disk, so that you can, as a user, you can select different volume type to get, for example, the better performance based on NVMe volume storage. And we do need some work for the dashboard for Magnum UI, because currently some of the features are still can be only accessed by the command line. The third thing we would like to do is we would like to containerize the master node so that you can totally, don't have to worry about the master node. We will fully manage the master node for you as a pod running on a root Kubernetes cluster by the cloud provider. And the last thing we would like to do is we would like to upgrade Fedora Atomic from 29 to Fedora CoreOS 30. Let's back to CE8. It's not really. OK, that's pretty much the session I would like to present today. Is there any questions?
Is there any way to handle the restart with this live migration that can happen anytime if your application that's running is not like a web app that's expecting short sessions, something that's expecting long sessions and they're not going to go away anytime soon? My use case is Samba. SMB shares can be open for months. How's that handled in the rolling restart?
Because generally there is a load balancer, in front of your service, and with the load balancer, usually, firstly the load balancer will make sure for long session it will keep the session alive, and if there's any the node down, is the node get down, the load balancer will remove that node from the load balancer.
Okay, so it relies on a protocol-aware load balancer doing things. Okay, sounds hard.
So as you can see, after 3 minutes, the AutoHealer is trying to, firstly it's called in, and is trying to call the OpenStack Heat API to mark that node as unhealthy, and then it will do the rebuild process. So currently, as you can see, the broken node has been removed. Later, we come back with ready status.
Hi. Oh. Hi. You said the thing you contributed back to Kubernetes was written in Go. Was that you originally wrote it in Python and then ported it to Go, or did you just develop it in Go straight away?
You mean for the AutoHealer?
Yeah.
Yeah, it's originally just written by Go.
Okay. And how did you find sort of the experience of working with Go versus Python?
It's hard to say. I think it depends on your experience. Generally, for my experience, I just read. I try to find the as soon as possible Go book, and just go through and then start to write the code and debug it. But the first thing I would like to warn is hard. I think it's hard in the Go world to do the debug, because in Python world I can insert the PDB anywhere I want, but for Go, the simplest way is just print log and run it. Yeah.
Thanks.